This one is about first lab on neural network implementation, or you can say first lab on deep learning. And in this lab, we are going to discuss how to train our simple neural network with an Mnist dataset, which is actually a digit recognition dataset. So first of all, it will have two parts. Number one, we will talk about the dataset, Mnist dataset, and how to use that one, what is inside this dataset. And the second thing would be how to use that dataset for training our simple neural network. So in the second part, we will build up a simple neural network and then train it with Mnist dataset. So I also assume that most of you already have some basic understanding of Python or using different Python packages. So that is the basic requirement of understanding this tutorial. So here, first of all, since we are going to use TensorFlow, so first we import TensorFlow and TensorFlow STF. So I have imported these three packages here, and also a SciPy. SciPy is also another package which has many similarities with NumPy as far as the scientific computation are concerned. So the first of all, what we do here, the TF version which I am using, I try to print that TF version. So how to print it, or how to run any statement in this cell, we have this is one cell, this is a second cell in which 1, 2, 3, 4 statements are written here, 4 Python statements are written here. This is the second cell. So if I want to run that cell, what I do, I use shift plus enter, these two keys. So when we use those one, the programming statements in a cell, they are executed. And one cell can be operated or can be used in two modes. One is a code node where we can write a Python program, and the second one is text mode, in which we only type a text, and after running that cell, a text is displayed, as you can see here in this cell. So here I have written text which is a markdown text, and when I enter shift plus enter key, so that cell is run, and we get this text output. So that Mnist dataset, it can be downloaded from a web address, or you can use TensorFlow packages to load that Mnist dataset. So what I have done here is this one is taking, you can say, a handler or object of this Mnist, and then if you want to download the dataset directly from the web, then you need to execute this line. So when you execute this one, so Mnist dataset will be downloaded to your workspace if you are connected to the internet. And since I have already downloaded to my local directory, so I am loading that dataset from my local directory using mnist.load data, and it is giving us the training data and its labels, the text data and its labels in this way. So if I run it, then after running, so the variables will be stored here in these, so the output will be stored in these variables. Now if I want to see the size of these variables, the dataset that I have uploaded on my variables, then I run this statement, print statement, which is given me, if I want to see the shape of this variable, I can use the shape. It will give me different dimensions of the shape. So I run it. So here you can see the X train size is 60,000 times 28 times 28. So it has 60,000 samples, and each sample is of size 28 times 28. Same is the case with test data. Y train is the labels of training data, and Y test gives us labels for test data. So now if you want to see any one image, so what is inside this data set, or what is inside these images, so we can plot those images. So for example, if I want to plot, let's say, all the training images are in variable x train. So if I want to plot any particular image in this x train, so what I can do, I can give it the index. For example, at 0th index, it is giving me what? Let's see what image we get. Image of 5. And if I want to plot, let's say, another image, what is the 11th image here? So this is 3. So in this way, we can also run a for loop for training number of images, for printing or plotting number of images in this data set. So I have done this one here in this code. Yes, if we move to here, so here I am using subplot, and this subplot is plotting one image, like this 0 image is one subplot. So subplot means that you have to plot 10 times 20, 200 images, and 20 images in one row. So here 20 images in one row, and I want to print those 20 images in 10 rows. So if you go down, we have these 10 rows here, starting from upward here, from 0 to the last line, last row, which is starting from 3. So in this way, by using subplot, we can plot number of images here. And this C map, it actually gives us the color map. So either we want to plot the color map of a binary in binary color, or we want to plot gray, like gray. So let's say if it's taking a long time or not. So now we can see that by using this gray value here, so it is showing all those images in black and white. So, and if you don't use any C map, then it will print all of these digits in colored form. So you can try it on your own. So these are the images, and then after that, yeah, just have a quick experiment on that one. That now we want to apply a filter, or you can say we want to do a convolution on those images. So how can we do that convolution? We use another package which is called SciPy. We have already imported that SciPy above, and we are using scipy.signal.convolve2d. So this is actually doing, because we are using images, so we need 2D convolution. So conv2d, that is serving the purpose of convolving this image or any image in our data set with this filter. So we define a filter first. I have defined this filter here, like this filter is size is 3 by 3. So the first row has these values, a matrix of size 3 times 3 or 3 by 3. The first row is this one, second row is this one. These are the values in second row. Third row has these values. This is a filter of size 3 by 3, and here we are convolving this filter with this image, let's say 10, or let's say the 21st image. So here run it. So it has convolved, it has given the output in this variable out1. Now if I print this out1, so you can see, wow. So the actual image was, I also had to change the index here. It was 20, and yes. So the image was of the digit 4, and now it have applied that filter. So you can see it has given us some features. You can see some edges in this image. So that was about some introduction of the dataset and a convolution operation on that image dataset. So after that, we are going to discuss about implementing or building up a neural network using TensorFlow, and then how to apply this dataset for the training of that neural network.